This is Math 139, Section 4.13. We'll be talking just a little bit about the arithmetic of complex numbers. Remember, a complex number is one that has both a real and an imaginary part. We've dealt with these a little bit already because of the fact that they arise in the context of solving polynomial equations. But we're going to look a little bit more carefully at exactly how these things work and how they relate to one another, even outside of that context. So again, just as a reminder, we found the imaginary unit, I, as the square root of -1. Based on that definition, let's play around first of all with some powers of I. I squared would be the square root of -1 squared. And as we've been talking about lately, the square and the square root are inverse functions. So we just end up with -1. What about I cubed? Well, I could write I cubed as I squared multiplied by I. Right? Second power plus a first power would be a third power. And we just said I squared is -1 times I is minus I. Now what about I to the fourth? Well, I'm going to choose to write that as I squared times I squared. Right? Again, 2 plus 2 is 4, so that's true. But I squared is -1. So this is really -1 times -1, or +1. Notice that that cycle of I squared, I cubed, I to the fourth would actually just repeat itself over and over again. If I had I to the fifth, I could think of that as I to the fourth times I. But since I to the fourth is 1, that's just 1 times I, or I. And I to the sixth would be I to the fourth times I squared. I to the fourth is 1. I squared is -1. So that's -1. I to the seventh would be I to the fourth times I cubed. I to the fourth is 1. I cubed was minus I. So that's going to be minus I. And I to the eighth would be I to the fourth times I to the fourth. 1 times 1, or 1 again. So that same cycle of I -1 minus I 1 happened all over again, and it would continue that same pattern if I went on to I to the 9th and I to the 10th and so on. All right. These are all what are called pure imaginary numbers. There's no real part to them, but we've seen that a lot of times we have both a real and an imaginary part added or subtracted potentially together. Complex numbers are our name for real part plus or minus imaginary part. And one thing that's really important in this section, especially when you do your problems in my math lab, we should always write complex numbers in this form. Put the real part, and then plus or possibly minus something times the I, that is the imaginary part. I'll make sure that we always write our final answers in that form. All right, so let's take a look at simplifying some radicals that give us imaginary results. 2 times the square root of -45 plus 6 times the square root of -80. So let's see, that -45 under that radical, I'm going to separate that. And I'm going to say, I probably want to go with 9 times 5 to break that down. And I'm going to put the negative here on the 9, because that way when I take the square root, it's just going to be a 3i. So the first part I have 6i times the square root of 5. Plus, I've got the 6, and again I got to break this down. Square root of -80. Thinking for the 80, I'm going to go 16 times 5. And I'll put the negative with the 16. Again, that's just going to come out to a nice imaginary number. So I have 6 times 4i, square root 5, or 24i, square root 5. And in this case, I'm going to end up with just a pure imaginary number. There's no real part. These are like terms, so I'll get 30i times the square root of 5. All right, here's a subtraction problem with some imaginary numbers. This works just like you would expect it to. I am going to have to distribute the minus. So minus 7 plus 3i. And then I'm just going to combine like terms. I do want to write the real part first in my final answer. So I'm going to do the negative 3 first. And then a minus 4i. And that's all there is to that one. All right, number 3. This is one to be especially careful with. You don't want to start doing any arithmetic with complex numbers until they're in their I form. Notice like up here, I got the I form before I tried to combine anything. I need to do the same thing here. Don't be tempted to multiply until you've simplified it and gotten that imaginary form. So on this first one, I'm going to break down that square root of 8 as the square root of negative 4 times the square root of 2, or 2i times the square root of 2. And then that negative 6, really that's just going to be a negative 1 times 6, or I times the square root of 6. Now I can safely multiply them because they are in their I forms. So outside the radical, I'll have 2i squared. And inside the radical, I'll have the square root of 12. All right, a little bit more simplifying to do here. I squared, we just talked about this at the top of this page, is negative 1. And I'll break down the 12 as the square root of 4 times the square root of 3. So I have negative 2 times 2 times the square root of 3, or negative 4 times the square root of 3. All right, I'll do something similar in number 4. I want to get the imaginary forms before I start to multiply these. And I'm going to start taking a little bit of a shortcut here. I can't break down that 2 at all. And I know that that minus is really a multiplier of negative 1. I'm just going to pull that out as an I. And I'll do the same thing here. That minus, I can pull that out of the radical as an I. So 5i square root 2. So I've written the imaginary form first, and now I'm actually ready to do the multiplication. This is a FOIL process, right? Binomial times a binomial. So I have 18, positive 15i square root 2, and then a negative 6i square root 2, and then a negative 5i squared square root 4. All right, let's do a little bit of simplifying. Got my 18 here. And these are like terms. So I'm going to have a plus 9i square root 2. And then I have negative 5 times the I squared, which is negative 1, times the square root of 4, which is 2. So let's see, negative times negative makes that a positive. 5 times 2 would be 10. And then I can combine the real parts. I do want to write my final answer with the real part first. So 28 plus 9i square root 2. All right, let's look at a couple more. In example 5, we have the imaginary number 3 plus 2i, and we want to square it. Just like any other binomial, when you square it, you need to make sure that you multiply it by itself. You can't apply a square across addition or subtraction. You got to actually multiply it out. So let's see, using FOIL, I would get 9 plus 6i plus 6i plus 4i squared. That's 9 plus 12i plus 4 times the I squared, which is negative 1. That makes that a minus 4. And I will both combine those, make that a 5, and the 5 is the real part, so it gets written first. And I end up with 5 plus 12i. All right, what about division? We're going to make use of some of the same little tricks that we already know for simplifying radicals when they're divided. We're going to do the same kinds of things with these imaginary numbers. So let's start here in example 6. I'm going to begin by saying I can't work with those until they're in the I form. So let me do a little rewriting here. That would be 4 plus 3i divided by 5i. When your denominator is just a pure imaginary number, there's no real part, the quickest way to simplify this is to simply multiply by I over I. What that's going to do, of course, is put a 5i squared in the denominator, and once we replace the I with negative 1, there'll no longer be any imaginary numbers in our denominator. So our goal kind of here is to get rid of I in the denominator. All right, let's do that. On top, I will have to distribute, so I'll have 4i plus 3i squared, and the denominator is 5i squared. That's really 3 times negative 1, so I can make that minus 3, and the bottom is really 5 times negative 1. So I can make that negative 5. Okay, so I've done this. I've gotten rid of the I in the denominator. The only thing left to do is to rewrite this in our standard form for complex numbers. So I'm going to write this one out in a couple steps, although you'll probably shortcut these eventually. What this really means is negative 4/5 I minus makes that a plus 3/5. But I've not quite got that in the right format. Remember, we always want to write the real part first. So I'm going to put the 3/5 first, and then the minus 4/5 I. And that's the way that the standard form is written, and that is the way that they'll expect you to write it when you input answers like this into MyMathLab. All right, our last problem. We're trying to divide 2 plus 4i by 8 minus 3i. Again, I'm going to take a page out of what we already know about radicals, and I'm going to use the conjugate when I've got a two-term denominator, a denominator that's a full complex number with both a real and imaginary part. So the conjugate of that denominator would be 8 plus 3i. And of course I have to multiply by the same thing on top. I always got to multiply by a form of 1, right? Okay, so it looks like I've got some FOIL problems to do here. On the top, I'm going to multiply and get 16 plus 6i plus 32i plus 12i squared. And on the bottom, again, I'm going to multiply and get 64 plus 24i minus 24i minus 9i squared. Denominator, we're not real surprised. This is what should happen, right? The middle terms add up to 0. That's what happens when you multiply by a conjugate. And then let's go ahead and simplify a bit on the rest of this. So on the top, I've got my 16. When I add those, I'll get a plus 38i. And then this is really 12 times negative 1, the value of I squared. So I'm going to write that as a minus 12. On the bottom, I've got the 64 minus 9 times, well, actually, let's do the same thing. Let's make that negative 1 also. So a negative 9 times a negative 1 just makes that plus 9. All right, we're almost there. I can combine those like terms. That'll become a 4 plus 38i. In the denominator, I've got 73. Again, everything's nice and simplified, but it's not yet in the format that we typically write or we want to write our complex numbers. We want to separate the real from the imaginary part. So I'm going to rewrite this as 4/73, the real part, plus 38/73, I, the imaginary part. And that's how you'd give the final answer on that one. All right, this brings us to the end of 4.13 and also to the end of the course pack.